Welcome to the first presentation in Unit 6. The title is Water is Wet. Water is the driving force of all nature. Leonardo da Vinci said that. And so, learning goals for this students will identify the characteristics of water that make it important to life on Earth. Number 2, we'll describe the unique properties of water. And number 3, explain the properties of water based on the chemical structure. So, what we should already know coming into this, water is essentially very essential for life on Earth. It is necessary for life on Earth. Water has a chemical formula of H2O, and water has very unique properties all to itself. Now, what we should have picked up in the lab, water is more dense in the liquid form than ice, so it will float, ice will float in water. Water can dissolve many different substances, and water has a high specific heat capacity, meaning it can absorb a lot of heat. Water has a chemical name of dihydrogen monoxide, meaning we have two hydrogens and one oxygen. And we can see that here it's represented. Here is the hydrogen, and then oxygen. The chemical structure of water can be seen here, and the chemical formula is H2O, as we've said. Examining water, looking at it a little more closely, the oxygen in water pulls the electrons in the hydrogen bonds closer to it, and so essentially, because oxygen has a very high electronegativity, it pulls those electrons in. And what this does is that gives the oxygen atom has a high negative charge. It has this high negativity over here. And the hydrogen atom has a positive charge. So essentially what we have is we have positive up here and we have negative down here. So we have that positive and that negative, which gives water some unique properties. The charges, we know that opposites attract and likes repel. So water molecules are attracted to one another very strongly. And this attraction, it has a specific name, it's called hydrogen bonding. And so essentially what happens is we have all these negatives are then surrounded by positives, and the positives are surrounded by negatives, and it creates a structure of hydrogen bonding, which gives it very unique properties. So let's look at the properties of water. Water is a liquid at high temperatures compared to other covalent compounds, because essentially these are just nonmetals bonded together. Water has a high density for a liquid, and water has a high surface tension. We saw that when we were putting the drops on the penny, and water dissolves many substances. And so water has very unique properties, and it all has to deal with the structure, the way that it's set up. With that hydrogen and that oxygen, the hydrogens being positive and the oxygens being negative. So solubility. Solubility refers to the ability of the substance to be dissolved, and it forms a solution. Water is a good solvent and can dissolve both polar and ionic substances. So it can dissolve some sugars that are covalent, and specifically ionic. And what this does is it basically comes around, and again, it's those positives, those negatives, and the positives and the negatives come around what it's dissolving, and it kind of separates it in what we call dissociation. It's a big word for just saying dissolving. Um, the ramifications of solubility. Water is used by chemists to aid reactions, and so to speed up a reaction, it's not like a catalyst, but essentially for a reaction to take place, if you put it in an aqueous form, meaning you make it dissolved in water, it'll happen at a greater rate. Now, water is used as a cleaner because it can dissolve many substances, and some minerals requires protection from water so they do not dissolve. So water is a very good solvent. The density. So solid water ice locks hydrogen bonds into place. We can see that right here. It locks them into place, and it causes it to have more volume. It expands. So water expands as it freezes, which makes solid ice float in water. So liquid water has more freedom to move. Solid doesn't. Locks it into place, more volume, and we know that density is mass all over volume. So if we increase our volume, we're going to have a lower density. Now, the ramifications of density. Ice will float on water. Ice forms an insulating layer, preventing oceans from freezing, and life continues in lakes and ponds that have frozen the surface over because they can doesn't sink to the bottom. If it's all the ice sank to the bottom, it would just refreeze and refreeze, and eventually you just have a solid block of ice for a pond. Now, water's state of matter. Water is a covalent compound, and most covalent compounds are gases at room temperature, but water stays a liquid until 100 degrees Celsius because of those hydrogen bonds. So, states of matter ramifications. Water stays a liquid when other polar substances are gases. Water can be used to dissolve more substances, and water can be used to cool very hot objects. We can see that here. Blacksmiths use them to cool objects down after they've heated that metal up and bent it. Surface tension. We looked at this with the penny in the lab. So the surface tension, the attraction between the positive hydrogen and the negative oxygen is so strong that it creates this pulling on the surface. And this allows smaller objects to walk on water. We can see the water bug walking here. And what we see is because of those hydrogen bonds, it kind of holds everything together. And all those water molecules want to hold on to each other. And we see here, surface tension allows liquid in thermometers to rise in a very narrow tube, and it causes formation of puddles. So let's jump into some examples. Fundamental A1, it says match the term with the definition below. So density, when we're looking at density, it's the amount of matter per volume. Solubility is the ability to be dissolved. State of matter, solid, liquid, and gas. And surface tension is the force to penetrate a liquid. Next question, it says, explain the following observations regarding the density of water. And so we see that cold water is going to be more dense than warm water because those water molecules are really close together because they're cold. But what happens is they reach a point where those hydrogen bonds start to form and solidify, and they hold them in place. And then we have ice, which is less dense than water. That's why it floats. Proficient A3, it says which requires more energy, changing water from a solid to a liquid or a liquid to a solid. Well, the law of conservation of energy says that if we form those bonds, those hydrogen bonds, energy that required to do that is the same energy that it requires to break those bonds. And so it's the same amount of energy, just different direction. And our last question, mastery level question, how would increasing the temperature of water affect the likelihood that water will form puddles? It will decrease the likelihood because if you speed it up, it starts to move around a little bit more and they kind of separate a little bit, and the hydrogen bonds have less of an effect, and so it's less likely to form a puddle. But essentially, water will always form puddles.